Hi and welcome to my free Java video course. My name is Markus Biel. In this episode, I will talk about the difference between a shallow and a deep copy. Without fully understanding the idea of shallow versus deep, we can already see that the expression is related to a copy. So let's start with the simplest question. What actually is a copy in Java? To answer that question, we have to differentiate between a reference copy and an object copy. As the name implies, a reference copy creates a copy of a reference variable pointing to an object. So we will have two reference variables referencing the same object. On the other hand, an object copy creates a copy of the object itself. So as you can see here, we will have two reference variables that each reference a different object. Shallow and deep copy are both related to an object copy. But what is an object actually? Often, an object is represented as a single coffee bean. However, that's just a very simplified view. Let's look at this in more detail. Say we have a person object. This person object is composed of other objects. Our person has a name and an address. The name object is composed of a first name object and a last name object. The address object is composed of a street object and a city object. So when we say person object, we're actually referring to this entire network of objects. So why would we want to make an object copy? An object copy, also called a clone, is usually created if we want to modify or move an object while still preserving the state of the original object. There are different ways to copy an object, for example by using a copy constructor or a clone method. In short, I do not recommend that you use the clone method to copy an object. For more details, watch my video about the topic. In this episode, we will use a copy constructor to create both a shallow and a deep copy. Now that we have a solid foundation, let me explain the actual difference between a shallow and a deep copy of an object. Let's start with a shallow copy. Here you can see the object structure of our person object again. To create a shallow copy, we only copy the main object, person. So a shallow copy references the same inner objects as the original person. Therefore, a shallow copy and its source are closely related to each other. As an example, a change to the address object will reflect in both persons. This is a problem if you need two truly independent person objects. In contrast to a shallow copy, a deep copy is a fully independent copy of an object. So we start again with our person object. But this time, we copy the entire object structure. Now, both person objects can be changed independently. A change in one of the address objects would not be reflected in the other person's address. Finally, a combination of a shallow and a deep copy is also possible. Fields that need to be changed will be deep copies. All other fields will be shared. Okay, I think we had enough of the circles. Let's just see the code. Just like before, we'll start with a shallow copy. So we have a class person, which internally uses a name and an address. The copy constructor takes the original person object and copies its reference variables. Okay, now that we've seen the code of the person class, let's actually make use of it. First, we create a person object called mother with a name and an address. Somewhere later in the code, we will create a copy of this person object and assign this copy to the reference variable son. The mother object will be taken as a basis for the son object, as they will both share the same address. Much later, when the son has grown old enough to support himself, he wants to move out. only to find out that his mommy has already joined him. To better understand what actually happened, let's revisit the code. Can you figure out what's wrong? Pause the video and think about it. Okay, so the issue is that in the moveOut method, we directly changed our internal address object by replacing its street and city objects. Because the address object is shared with our mother object, that change reflected in both person objects. To fix the issue, we could simply assign a new address object to Son. Just for the record, however, please note that our Son object wouldn't be a true shallow copy anymore. In conclusion, if used correctly, a shallow copy may be fine, but it could also lead to unexpected behavior. Last but not least, let's look at the code used to create a deep copy of the person object. Again, we use a copy constructor, but this time we will create a deep copy of the object. So we create two instances of name and address by using yet more copy constructors. But actually, that's not the end of the story. For a true deep copy, we have to continue copying all of the object's nested elements until there are only primitive types or so-called immutables left. Let's look at the street class to better illustrate this. The street class consists of two instance variables, string name and int number. Let's look at the int number first. It is a primitive value and not an object. It has no reference variable. It's just a simple value that can never be shared. So when in the copy constructor we say this.number equals otherstreet.number, we're automatically receiving a copy of the value. The other instance variable, name, is an object of type string. However, string is an immutable. In short, an immutable is an object that, once created, can never be changed again. Therefore, you can share it without having to create a deep copy of it. Now that we're using a deep copy, the Son can successfully move out. Hooray! However, as a final note of caution, please note that just because a deep copy lets you get away with this, don't infer that I suggest you do so. Directly changing the internal details of an object is bad code style and should generally be avoided. In our example, I would recommend using a new address object instead. Okay, that's it for this episode. In my next video, I'll tell you more about Java immutables, which spare you the hassle of object copying. If you have any questions, leave a comment below this video, and please remember to give me a thumbs up before you go. Thanks for watching, and see you next time.